Welcome to the section entitled The Command Line of Building an Application with Haskell. In this section we will learn about parsing command line arguments using the optparse-applicative package, defining algebraic data types to specify the data model of our command line options, and we'll finish off our parser, and this will include subcommands and full command line help. In this video we're going to take a look at the optparse-applicative package for parsing command line options. In Haskell we have many options for parsing command line arguments, including getargs from the system.environment module in base and various third-party packages on Hackage. This is a page entitled Command Line Option Parsers from the Haskell wiki. It summarizes a number of third-party packages available for doing this. Optparse-applicative listed here is the one we'll concentrate on, but there are many others. What does optparse-applicative offer? Its advantages are that it generates pleasant POSIX-style parsers, it's type-safe, it's powerful and extensible, it has good error reporting and usage information to the user. Its use of algebraic data types makes it easy to represent subcommands. And it feels very Haskell-y in that it encourages the developer to build up complex command line parsers from smaller parsers by composition. What distinguishes optparse-applicative parsers and those available from other third-party packages in the Haskell ecosystem from parsers in other languages is that the types tend to drive parsing. They will typically generate the parser and help messages from the same types with very little redundancy or boilerplate, and they will typically also guarantee that all cases are fully handled by the parser. At its core is the parser of A polymorphic type, and this represents a specification for a set of options that will yield a value of type A when the parser is applied to the command line arguments. And its functor, applicative and alternative instances allow us to compose parsers in various different ways, as we'll see later. To build parsers we'll use various functions, such as argument. This builds a parser for positional arguments, and it takes a reader, some options, and evaluates to a parser. Auto. This can parse arguments using the read type class instances for a given type. It's a commonly used reader and it can be consumed by argument. Additional aspects of individual command line option are also specified using functions, including metavar to associate a meta variable with an argument, which provides a symbolic name for arguments in help text, and help to associate help text. And there are many, many others. Don't worry too much about these type signatures for now. As we start to string these functions together, we should build up an intuition for how to use them. The functions that we'll use to run a parser in optparse-applicative are as follows. Info takes a parser, an information modifier, which is used to provide global options such as description and headers, and evaluates to a parser info of A. Progdesc is one such global option and provides a global description string for the parser. Exec parser takes the parser info of A and yields an IO of A action that yields an A when the parser is applied. Let's create our to-do project. We'll start with the 6 basic files we need for a stack-based project. Firstly, .gitignore ignores the .stack-work directory. We then have a license file, a readme file, a simple stack YAML. This specifies the LTS 7.8 resolver. A simple cabal file. This defines our first target, which is an executable named to-do-exe. And our source directory is the app directory containing main.hs. Simply says hello world for the time being. This should compile, run, and display hello world as expected. Stack build --exec to-do-exe. This will build the project and then execute that target. Prints hello world as expected. Let's open our editor. Here's our editor. This is the project. to-do. We have our embedded terminal running. And we're going to run a file watch build. Stack build --fast to bypass optimizations, --file-watch to wait for changes, --exec. And we'll execute the to-do-exe target. Hello world as expected. Here's our cabal file. We'll add the optparse-applicative dependency and save. It rebuilds. We'll open up our main source file and we'll add an import statement to the top. Import options.applicative. So this application will store to-do items in a list on disk, and we will need some way to reference them. And indexing them by index is as good an approach as any. So we'll define a type alias for int. We'll call it item index. So type item index equals int. I'll write a simple parser for this. Item index parser. This will have type parser of item index. So item index parser equals argument. We'll use auto, so we'll use the read instance for item index, which is the read instance for int. We'll have a meta var item index that will show up in the help, and help message index of item. And these options are combined using the less than greater than operator. We'll now combine the runner functions from before in the slide to build our main function. Main equals do item index from exec parser applied to info item index parser. We'll have a program description of to-do list manager. And this will run the parser in the IO context and yield the item index, which we can then print out to the standard output. Put_learn $item index equals ++ show item index. Let's save that, make sure it compiles. Excellent, it compiles and runs, and it says missing item index, since we need to specify this in the command line. This is a required positional argument. Let's go to our terminal. We'll do stack exec -- to do exe. It lists the command line help, and we'll even pass the value now. It'll say cannot parse value, since foo is a string, not a representation of an integer. Let's provide a valid value. 1, 2, 3. There we go. Item index equals 1, 2, 3. Now let's instead create a parser for a file path. And this will be the path to a data file, and we'll have a default value. Here's our main.hs. We'll have a default value for our file path. Default data path will be the name. We'll have type file path, which is an alias for string. Default data path equals. This is going to be the default file name that we use for our file path. .to-do.yaml. Tilde to represent the home directory for the current user. Let's write a parser for that. Data path parser is a parser of file paths. This will be a string option. This is a function from optparse-applicative applied to value, which is an attribute of the option. It specifies the default value, which will be default data path. We'll use this less than greater than operator again to specify other options. Flag for the option will be data-path, so it will be --data-path when run from the command line. We'll take a short form of p for path. A meta var of data path. And the command line help, path to data file. And we'll specify what the default is in the message. There we go. Now we'll change our main function to parse data paths instead of item indexes. Comment that out. Data path from exec parser info data path parser prog description of to-do list manager. And then we'll do put_learn $data path equals ++ show data path. Save, make sure that still compiles. Great, let's test that out. Stack exec ---to-do-exe --data-path foo, that's the long form. P for the short form, foo. We'll run it without specifying it at all, since it has a default value, which is tilde/.to-do.yaml. So here we've seen how to parse different types, integers and strings, as well as positional arguments versus options. In the example given here, we can run either the item index parser or the data path parser. We will want to combine parsers, and we'll learn about that soon, so that we can run both of them in some form or another.